Molecular formula. A molecular formula indicates the number of atoms of each element present in the molecule. The molecular formula of a compound is either the same as its experimentally determined empirical formula, or it is a simple whole number multiple of its empirical formula. An empirical formula provides the simplest whole number ratio of atoms or moles of each element in a compound. Examples would be H2O, HO, and CH2O. A molecular formula represents the actual number of atoms or moles of each element in a compound. So we have H2O, which is the same as there, but here we have H2O2, which has a whole number multiple of 2 times the 1 hydrogen and the 1 oxygen. Then over here we have C6H12O6, which is 6 times the amount of atoms in CH2O. There are 2 reasons for determining an empirical formula. First, ionic compounds contain widely varying numbers of ions, including polyatomic ions. Only the ratios of the different ions is fixed. So only the empirical formula of an ionic compound is meaningful. Their molecular formula is not relevant. Reason 2. 2 different molecules can have the same ratio of different atoms, but behave very differently. In that case, their molecular formula defines the molecule, but can only be obtained by first finding the empirical formula. To find the actual molecular formula, you need one other piece of information. That is the molecular weight, or the mass, molecular weight, molecular mass, of the molecule. If you know the ratio of the atoms in a molecule, and you know the total mass of the molecule, then you can determine the molecular formula. Let's try a problem. Given the empirical formula, CH2O, for compound X and a molecular weight of 60 AMU, find the molecular formula. First, determine the ratio of the molecular weight to the empirical formula weight. So here's compound X, 60 AMU, and here's the empirical formula weight of CH2O, 30 AMU. The ratio is 60 divided by 30, 2 to 1. The molecule is twice as heavy as the empirical formula. Next, multiply each subscript of the empirical formula by the ratio determined in step 1. So CH2O times 2 will be C2H4O2. That is the molecular formula. Here's some more examples. Here we have a formula name of CH. That's an empirical formula because you have the lowest whole numbers there, right? 1 carbon, 1 hydrogen. The molar mass of CH is 13. Then we have C2H2 ethene. That's a molecular formula. That is a factor of 2 times the molar mass here, so that's 26 is the molar mass. You can see we have 2 carbons, 2 hydrogens, where the empirical formula had 1 each. Then if we multiply it by 6, we get benzene, C6H6. Once again, a molecular formula, and 2 very different compounds. And that would have a molar mass of 78. Now, let's go over to methanol, CH2O. That's both empirical and molecular. That's the lowest whole number ratio, 1, 2, and 1, but that's also methanol, and that has a molecular mass of 30. Then, if we double each one of these, so we have 2 carbons, 4 hydrogens, and 2 oxygens, that's ethanoic acid. That's a molecular formula, right? Because it's 30 times 2, 60. Then, if we multiply this, the empirical formula here of methanol, by 6, we get glucose. Again, totally different molecules here. And that, once again, is a molecular formula, and we have 6 times 30 with molar mass of 180. What is the molecular formula of a compound with an empirical formula of CH2O that has a mass of 180 grams per mole? To find the molecular formula, step 1. Determine the molar mass of the empirical formula. And the answer will be on the next several slides. Okay, step 1. The molar mass of CH2O is 30 grams per mole, and we get that from the periodic table. Now, step 2. Divide the molecular mass by the empirical mass. Step 2. Divide the molecular mass, which is this 180 grams per mole, by the empirical mass. The empirical mass is 30 grams per mole. So 180 grams per mole divided by 30, we get 6. And finally, multiply the empirical formula by the whole number found in step 2. So here's a whole number in step 2, and we have here's our empirical formula, and we get C6H12O6.